Hey everybody, so I'm looking at one of our interactives. If you go to your classroom, you'll see it right here. This is the Painting with CMY interactive. That's this page. And then Painting with CMY exercise. That's this page, which, as you recall, you can take care of. You can do a copy on a piece of paper. You can do brain. You can use a PDF editor to actually work with this sheet. You can print it out and take a picture of it if you like to work analog, that kind of thing. So I keep doing this to myself. There we go. Bam. Okay, so look here. And what we're going to be seeing is how to make the colors for this football uniform match what the team wants. You're pretending that you have like a printer, a like clothing printer, and you're printing out clothing. Because when we do printing of any kind, we can't use red, green, and blue. Last week we learned how red, green, and blue, the color and light, is used to show things. So if I have something that is red, like on my little packet here, there's reds and greens, then light makes red. Light is what's needed to have this red color show up on this. But we're going to talk about color subtraction theory, which is basically how pigments work, paint, or dyes on your clothes. Okay, because those aren't light. Those are what light bounces off of, what reflects from. And so we actually take the secondary colors and use that to make things happen. So for example, here we have cyan, magenta, and yellow. If I click yellow, hey, it's yellow. I put yellow on his helmet and it's yellow. If I put magenta, it's magenta. If I put cyan, it's cyan. But what do I do if I want like red, right? How am I going to possibly get red? Because it's not an option on here. Well, you see, if I combine magenta and yellow, what do they both have? Both have red, right? So there's way more red on that helmet than there is green or blue. And so red is what we really see. Red's the only thing you're going to see if this is mixed perfectly. Okay? And you'll see green because cyan and yellow both have green in them. Or you could see blue because magenta and cyan both have blue, right? And so you get way, way tons of blue and not that much of the other colors when you mix them together like that. And then you can see the primary color you're looking for. So our interactive here says, hey, the Chicago Titans here, they want the helmet to be blue. Well, I just showed you that, right? Well, okay, they want a blue helmet. Well, I'll take the two guys that have blue in them, and I got a blue helmet. And you just go over to here, and you're going to circle C and M. Or you could go on a Google Doc and just be like, Chicago Titans helmet C and M. And that tells me, yeah, it's going to be those two together. And then we go down here. Here's the Washington Knights. And they want their helmet to be red. Well, figure it out, right? But then we go down here, and there is a advanced mode. And it says that we want an olive green helmet, and we're using percentages. What does that mean? Well, there's an advanced mode here, okay, where you can choose, what percent you have of certain things, right? And so it's like, hey, I want olive green. And I'm like, what is olive green? That seems like olive green to me, okay? And then it says they want a tangerine shirt. How can I get a tangerine shirt? Right? And you're going to work out, like, what color is tangerine? Like, what is it? What mix of colors is tangerine? You can go through that. And then the last two are free choices. You're like, pick a color. Pick burgundy or maroon or sea green or something. And, get close to it. And that's what this part is about. And then here, it's asking you what you get if you mix everything, and it's kind of going through the same idea again. And then down here, these are color equations. It's not actually math, right? It's like an equation because that's kind of how it works mentally, but you're not doing regular math with numbers, so don't worry about that. Instead, what we're doing here is you're going to be setting it up so that you have R and G and B light gives you what kind of light, right? R and G light's what kind of light, right? And you can just talk about all these things, kind of figure it out, like based off what it's telling you about these things, right? Because RGB light is white light, red, green, and blue together as light, is white light. That's this part. If you have any questions, hit me up on Discord. Next question, or next thing, this is Young's experiment. I really want to show you guys this in the class. I actually have like a laser and double slits. We could have really done some cool stuff with this in the classroom. Unfortunately, we're all home right now. So this is an example of it. And the thing is, you have this laser that is wide enough to hit both slits, right? And pardon me, this is the pattern that is made on a wall behind those slits. And remember we had this with waves before, where we talked about, hey, remember if you have a wave hit like two little holes in a wall, then it diffracts out and you get this kind of like weird interlaced pattern. And there's constructive and destructive points, and that's why like you can hear sound really good in some spots and not hear it at all in other spots. This is the same thing with light. And if you watch the videos that are linked as material in this lesson or this unit for the classroom, I can scroll down and show you what I'm talking about. In fact, I want to make sure you guys actually remember this is a thing that we have, okay? These are these materials that are really helpful. Like this con explains all the stuff you're learning in some videos. Easy to watch, okay? And then other things here too that really give you some cool stuff to look at. Man, I'm yawning. But that explains this, like the waves kind of overlap on each other, right? Kind of like this. And you get this pattern. And so you're going to be like kind of messing with these, seeing how all this stuff changes, picking the different colors of lasers. And you're going to go through here and you're going to answer. This is important. Make sure that you follow along to exactly what I'm saying. You're going to answer the conceptual analysis. You are not going to do the mathematical analysis. You're going to do the conceptual analysis. And the reason why is that the interactive we have is really fiddly. So it's really easy based off you like reading it wrong. For example, down here, okay, part of the math analysis is making sure that the middle of this constructive point and the middle of the next constructive point are like exactly 1 centimeter apart. That's an important that's part of how like you'd actually do this math. But when is it exactly 1 centimeter? Is that like when have I hit the right number? And if you don't have it like pretty close, you could be off by enough that your math doesn't work, and then the thing says, no, your math is wrong. And I want you guys to like be wrestling with that over and over again. It'd be a huge pain in the butt. Okay, so don't have to worry about doing that part. Just read the conceptual. Sorry, I am so yawny right now, man. But you don't have to worry about doing the conceptual part at all. Sorry, the mathematical part at all. You're only doing this conceptual part from here down to here, right? Questions 1, 2, and 3. That's it on Young's experiment, okay? And so you can get these done whenever you feel ready to. And tomorrow, I will put up the explainers for the concept builders. Good luck on those, and good luck on this. Have a good day, guys.